Hello everyone, good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Very good morning, one and all. So I hope everyone has done their installation part, right?
Yes, sir.
Yes, sir.
Okay.
Excuse me, sir.
Yes.
Sir, actually, I have not done this part because, sir, my laptop charge plug is not working. So uh, the shopkeeper doesn't open the shop right now, and I that laptop is not available with me.
Okay. See, I have given you 1 week time because of this
Sir,
only.
last week he doesn't open the shop, sir,
Fine, fine. No
because
issues.
uh,
See,
his grandfather expired, sir.
fine, fine. Okay, okay, fine. No issues in this. I have given you enough time. So it's up to you how you will going to monitor this, how you will going to practice. It's up to you. Why? Because I have given you 1 week of time, and from today onwards, I am going to start the session, start the software and everything. So you know you need to collect all the inputs. I mean all the data and everything. So once when your laptop will be received or once it was go repaired, then you need to install it and you need to work on all these things. It's up to you. Okay. I'm not going to
Okay,
pause or I'm not going to stop the session anymore. I will
okay,
be
sir.
continuing
Thank
you
you.
from today. So not only with you, everyone. So if you are having any difficulties, kindly sort it out. Okay, but I'm not going to stop it. I'm going to start from today itself the software and all the things how exactly we need to work and what are the different things, the practicing, all the tool description, everything that will start from today itself. So whenever you will be having time you can practice it, or if you don't install the software, no problem. Whenever you will be having the PC with you or whenever you will be having the software, at the time you need to collect all this data and you need to practice it. It's up to you. Okay, now I will be sharing you something. I hope everyone joined with the teams only, right? I mean with the laptops only.
Yes, sir. Yes, sir.
Okay.
Yes.
Is it visible?
Yes, sir. Yes, sir.
Okay, fine. Before starting it, I will tell you one thing. So you have done the installation, right? Everyone.
Yes, Yes, sir.
Okay.
Yes, sir.
Kindly follow the same procedure. So this is what exactly the plant simulation icon will be. Okay. Just have a look. Later you can practice it. So this is the plant simulation. You can double click it and there will be a pop-up here. So how to check whether your software is perfectly installed or not? That. So you need to click this one, create new model. If there is a pop-up that will be opening this one, then your software is perfectly installed, which means you are ready to use. So if you are not receiving this one and if you're receiving any, I mean error message, then there is an error in your installation. That is the first thing. Okay. Now, before entering into it, so this is what exactly the plant simulation tool will looks like. And here by using the presentation I will be explaining you what are the different things in the introductory session, which means on the software basis. So what are the different tools, how exactly it will be used, all the things I will be explaining you in today's session. From tomorrow we will going to start how to work with the tools. So how to prepare a simple model, so what is the base of all those things, that we'll be discussing from tomorrow's session. Okay. Simply see here. This is a ribbon tab where you can go for all these things. If at all you want to create a new one, then it's new. So if at all you want open your previous model saved file, or if there is a file that was saved and you want to operate it or you want to modify it, then you are going to use this open one. This is a team center integration. So this I will tell you later. This is not comes in the training part. And share, if at all you want to share the file directly to the mail or something, then share option. And there is one option here, preferences. So if you click this preferences, then there will be a pop-up. Okay, this is completely for the plant modification or the simulation, the software modifications. How exactly you want to modify your file. So what are the default things you want to consider? Those things will be given in this preferences tab. Is it visible exactly?
Yes, sir.
Okay. See here in the general tab. First one, what is this one? Model language. So which language you want to opt? So here we are using English, so that will be default English. At the same time, date and time format. So once you have prepared the model, so you need to collect a report. That report will be collecting this information like the date, time, in everything. So how the format will be, that format can also be described. It should be 12 hours or 24 hours. At the same time, how you want to differentiate the time hour and how you want to differentiate the dates, all those things will be given default here. After that, model saving history. So how you want to save your model? So only the model which you have created, or without comments or comments, all the things. Generally we used to save the model with none only. Why? Because so whatever the error message, that will also be saved in these two things. That is why you need to save with none. And second one is this one, visualization report, which means it is asking, see, whenever I click this one, so what it is asking, 2D and 3D. So this is what exactly it represents. So whenever you are opening it one, so how exactly it want to open? So whether it will open directly a 2D model, or 2D and 3D model simultaneously, or directly a 3D model, or is ask each time. This is what it is. So if you put this default one, what will be happen? So whenever you click this new one, so automatically it will ask you this one, so which model you want to operate. So in general, the default is this one. So if you want to prepare directly 2D model, then you need to click this 2D icon, so it will be 2D. See, if I click this one, sorry, okay, now if you click this one, directly a 2D pop-up will be opened. Let me close it. Now file, preferences. Now ask each time. Now if I click this one, again it will ask me. That is this visualization. Next one is convert automatic angle. So these are all other things. So when you go into this completely software, then these things will be useful. After that, additional libraries. So they will be having some default libraries the plant software is using. So if at all you want to use them, there is no need. If at all there is a additional thing, so you have imported some additional features from external sources, then you are going to open this one, library directory. So you need to open that one and you need to select that library, so that sort of tools, that sort of things will be visible here. That is additional libraries. Second one is simulation. Simulation is nothing but how we are going to do the simulation part. See, these things, simulation units, unit preferences, these things, once we will enter into software, I'll explain you. Why? Because before explaining all these things, what is a simulation, how we need to do this, then if I try to explain all these things, it will be a mess. That is why I'm not going to touch this simulation part as of now. Next one is units. I hope you know SI and CGS. So if at all you prepare a model, so on what basis you are going to collect the results, that is defined here. So if there is a mass, that will be defined in kg. So if at all you want to change, you can change like this. Currency, so how we want to use this currency here? So we are selecting the Indian, that is why it is coming rupee. Otherwise there is a dollar, euros, and everything will be there. So default is at the same time speed. So what, how you want to calculate the speed? So whether with respect to kilometers per hour or meters per second, so based upon this you want to give your some plants will be using kilometers per hour, kmph. Then you need to go for this one. So default is meters per second. Same with the acceleration, same with length. So how you want to use the default length? So whether you want to use centimeters, kilometers, millimeters in your length, that can be defined by using this one. Some plants will be using the layouts in the only, millimeters. So they will be giving 15,000 millimeters or 25,000 millimeters. At that time you need to define this one, millimeters, and you want to do for model. So some plants will be using kilometers, some plants will be using meters. In general, plants will be using meters. So default is meters. Same length LU, which means once you have created the model, there is a dots that will be representing this one. So a dot to dot distance is nothing but this one, 1 meter, which means see, there is a dot here. This dot to this dot, the distance between these two dots is this one, LU. So how we want to differentiate, whether you want to differentiate meters or centimeters, how we want to differentiate, that will be defined by using this one. These are all interlinked. So if you click this centimeters here, and if you click the length meters, then there will be a problem. Whatever you are using here, you need to differentiate it by using this also. Okay, meters and meters default. Fine. Okay, user interface, editor, 2D, 3D, and licensing. Okay, fine. As of now, I'm closing this one. Okay, so I'm closing the software. And one more thing. So whatever you have done the modifications in this preferences tab, so after creating these things, you need to click OK, and you need to close all your open models. You need to close the simulation, and rerun it, then only it will be implemented. Now this is what exactly I have given the initial preferences. Now I want to start the simulation software. So for this, first one is, now don't work with example models, videos, tutorials. Why? Because again it will be having lot of things involved, you will be getting confused. So directly click this one. So if you are having a, if you want to create a new model, then directly creating a new model. In it again it will be asking 2D and 3D, two different things. And there is one more pop-up here, open model file. If you're having a file that is saved already, that you can be click that also, like this. See, in my software, practice files, plan sim, there are a lot of files here. So if I click something, models robots one, so it will be opened like this, and I can run the simulation. Close. Okay, that is what exactly open models is. Recent models, see what are the recent models. This is the recent model, robot one is the open, which I have opened here today, and there was one more file that was opened. So all the recent models will be listed down here, so you can check by using that also. I don't want it, so I am exiting it and rerun the simulation here. This is the last model file. If you directly want to open the last model file, then directly you need to click this one. So if you click this one, it will be, just a second, redirect to the last working model. Okay, so once a model was opened, now we want to close it. No need to close directly, don't close directly by using this into mark or this mark, close mark. So the step by step procedure is file and close. So what will be happened here is all the files that were unsaved here, that will be saved, or else it will ask you to whether you want to save or not. All those things will be clearly possible with this only. If you click this one, it will ask you whether you want to save the model or not. So if you click this one, sometimes what will be happen, the file will be collapsed, or if there will be having large number, too many number of components, it will be get messed with this close button. That is why this is the correct model, file and close. Just like you are creating a new, that is the only reason you need to close this also. Okay, now we want to work with create new model. So initial everything, every drawing or every model, anything starts with a 2D only. So we are going to work with respect to 2D itself. So initially you need to click 2D. So once you are familiar with 2D, all the basics of 2D, all the principles of 2D, on the working knowledge of 2D, then you are going to enter into 3D environment. So don't directly enter into 3D. Why? Because you will be getting easier in 3D. So once you learn the 3D, then again it will be difficult for you to learn in 2D modeling. So that is why first you need to learn the 2D modeling. So you need to select the 2D. Then this pop-up will be opened. Okay. Now I will explain you what are the different things. What are the all these things in this by using a presentation. Okay. See, there is a simple presentation here. I don't want all these things. Yes. See here. Okay. Now this is the plant simulation model or a plant simulation page. Here there are four things you need to consider. Even if I go for it, see there is this one. There are four things. One, two, three, as well as I need to select this console also. Just a second. Start icons, vector graphics, comments on. Where is this console? No need. Once we will be entering in software, then it will be visible. See here, this one is a class library. Okay, class library is nothing but what are the tools in the plant simulation. What happened? This is class library. Class library simply indicates all the tools in the plant simulation that were completely defined in a structure, that is called as a class library. See here, this is the class library where all our tools, all our models, whatever the working. See, this is a frame one. So if you are preparing n number of frames, all the things will be in this model one, model two. See, if I click like this, new or derive model one, duplicate model one. If I think folder new folder is there, in that I want to create a frame. So this is called a class library, which means all our programs, whatever the program which we are performing here, whatever the model which we are performing, everything will be defined in this one. This is a structure of the model which we have prepared. That is why we call it as a class library. where all the things, all the models will be saved here in a step by step procedure, in a structural model. So if at all I want, there are two models here. Out of these two models, which is main and which is subclass, I want to define that. Directly I can't define by seeing these two, but if there is a class library is there, then I can see this. See here, this is the model, and this model one, I mean this file is a subclass. That is what exactly the main necessity of class library. I will tell you when the software usage how these class libraries will be used. Okay, that is the first one. Second one is toolbox. This is what exactly the toolbox. See here, this is toolbox. I will explain you all these things today itself. The toolbox. Then there is one more thing, root frame or mainframe, and this one is console. Okay, this is called as a frame where we are going to create our model. Frame is nothing but where this is a platform where we are going to create our model. So 2D 3D, whatever the component, if you are having multiple frames, all the things will be defined in this frame, which means a working area or workspace. This is called as a frame. And one more thing here, console. This is nothing but message. So if at all I selected some component here, then there will be a message here pop up. If at all you want, I can directly, just a second, let me show you that also. Console. Yeah, see here. See, this is a console, which means message. So if at all I want to connect it, so what are the different things here? So what is the message? If at all I want to connect this with using this one, see here, console, if I click this one, it will be showing me some message link. See, there is a left click control insert command, hold down the control to insert the right objects. So that is what exactly a message that will be happened here. Or if at all I want to write something here, that can be pop up here. That is what exactly the main usage of console. Or command, if at all I want to write some model command or something, then I can directly write here. That is a console. Okay, now I am closing everything. The runtime error occurred, access violation, simulation time. Okay, what happened? Model was closed, software was closed. Okay, create new model. In the model I will be selecting 2D. Now see, this is the model. Okay, now I'll explain you what is this class library and what is this toolbar. Okay, toolbox. Generally all the tools which will be involved in the plant simulation are there with this toolbox itself. You can directly, if at all you want to move it. See here, I want to move in the side, then I can place it like this. I can drag it, then all my tools will be at this position. Now I don't want it, I want it at the bottom. I can directly click by using like this, based upon my convenience how exactly I want to place. I can place like this, and I can decrease its size. If at all I want, I can decrease its size. Okay, that is one of the thing. Now if at all you don't want to change all the savings, then click no and again new. Your power will be raised. Now I will be closing this. I will be opening the plant simulation software again from the starting. I will explain you all the things in detail. 2D, fine. Now see here, uh, I will be explaining you, I will be elaborating this one, fine. Then first one is a class library. So what is a class library? I have explained you.
Where all programs are defined.
Yes, where the structure of the program is defined simply. Okay, see all these toolbars. See here, there are material flow and there are these many toolbars. All the tools, these tools will also be in this. See here, connector, connector. There is a time, there is a time. There is a frame, there is a frame. If we go to this tools last bar, if you open this one, there are 1 2 3 4. If you click this one, there will be 1 2 3 4. So if you click this user interface, there will be having 1 2 3 4 5 6 7 9. So if you click this one, where is this one, user interface, there will be having these two. Okay, these both are same, but if at all you want to derive new objects, or if at all you want to define some relationship, then you are going to use these things. That is a class library. See here, in the class library there are tools. The tools are same in this toolbox. First one is a material flow. Material flow is like, so if at all you want to create a model, then these are the essential things to create a model. That is called as a material flow objects. First one is, before starting into this, I want to tell you this one, event controller. There is a time here, okay, which means the complete simulation model or the complete software will works with respect to time only. Okay, so whatever the model you have created, if you have created 200 models or 200 missions or 20 missions or even 2 missions, those missions work with respect to time. That time can be controlled by using this one. This is called as a controller for this complete simulation. So even the model is bigger, that will be controlled with this event controller only. Okay, event controller is one of the important thing to control the complete model which you have prepared, or to test the model which you have prepared by using this one. This is called as a event controller. Okay.
So can you please explain it again?
Yeah, yeah. See, I have prepared two different mission. No, not like this. Whatever the model I have prepared here, so if the model is having 5 missions or 10 missions, that 10 missions can be controlled with respect to one thing, that is nothing but a time. Okay, this complete plant simulation will work with 5D concept, I hope you know. In that 5D concept, 3D is nothing but three dimensional, and fourth D is time, and fifth D is cost. So this complete plant simulation works with this fourth D only, time, with respect to time. So whatever the model which you have prepared, that can be tested, that can be optimized, that can be checked. On what basis we are going to check? We are going to check with respect to time only. That time can be defined by using this event controller. Okay, see, there is a clock symbol that is represents here event controller. If we double click this event controller, then there is a pop-up. Okay, that pop-up is nothing but event controller. Here time is 000. Why? Because there is no any time given here, that is why 00. And there will be having some controls here. These controls are reset. This is called a reset simulation. Once we have prepared the model, then we are going to run the simulation. So for the running a simulation, first we need to do the reset. That is reset. And I will explain you when the model is created. This is called as a play and pause or a start and stop of simulation. If you click this one, this simulation, what is the model which you have created, that will be run. That is start stop. If at all you want to start, that is the thing. If at all you want to stop, this is the thing. And this is like a fast forward. If at all you want to complete the simulation at some regular intervals, this is a fast forward. And this is a complete faster at the end of the simulation, how it will be. If at all you want to check, that is this one. And event debug, if there is a problem, if there is a error, you want to check that one, then you need to click this one. Then you will be having all the breakpoints. This is error, this is error, this is the time, that you can check by using this one. In general, this event controller can be used to run the model. So all you need to do is you need to double click this one, then this pop-up will be raised. In this pop-up you are going to use these two commands only. So first one is a reset simulation, which means you are resetting the simulation. After that, you want to run this one by using this one. And there is a regulator here, speed controller, with which you can control the speed. So how we want to visualize, whether you want to visualize in a slow manner, which means each and every human will be visible here by using this speed. If you click this one faster, what will be happen? So the model, if at all you want to run the model for 1 hour, so this simulation will complete in a 30 seconds. Why? Because you click this 100% of time. So this 1 hour will be automatically controlled by using this faster, and this complete simulation will be done in a 2 seconds or 3 seconds of time. That is why you want to select this one. And real time, I will explain you when the model starts what exactly this real time is. Now I am closing this one. That is event controller. Next one is frame. Frame is nothing but this one. This is a frame. Okay, the model which we are preparing here, this is called as a frame. Okay, if at all I want to prepare multiple number of layouts, multiple number of models, then I need to create multiple frames. Like I want to create open, see, there is a new frame. This is frame 1 and this is frame 2. If at all I want to create new, What happened? The structure of the frame is currently locked. Okay. See. Again, I want to add new, then click new. So there will be new will be written here. If at all you want, you can directly create the frames, multiple frames. If at all you want to create a model that is having different frames, that can be defined by using this frame. Okay, we will be working with when the software starts. After that, next one is interface. Interface is nothing but, so you have created a frame, you have created two different frames. This is first frame and this is second frame. You have two frames. If at all you want to connect these two, which means one model is entering into this one, I mean one workpiece is entering into this one, definitely it want to enter into second frame, then it will be happened by using this interface, which is a connecting point with the previous frame. So if you double click this one, there will be having again some pop-ups. Okay, that is interface. Next one is important thing, that is called as a source. Source is nothing but input. So how you are going to give input to the plant, that is source. At the same time, there is one more thing that is called as a drain. Drain is nothing but output. So the plant that will be having input and output. Now what is the thing that need to have in the middle? See, if at all this is my plant, I will be having input ready, I will be having output, I am waiting for the output. I am having event controller, I mean I am having time. Now how can I supposed to convert my raw material into finished good? What is the thing I need here?
Assembly and process.
Process. Simply process. Again, if there is a process, what should be we will be having? We will be having some missions involved in that. Those missions are nothing but this one, station. Okay, so if I click this one, station is nothing but a mission here. In this plant simulation language, mission is nothing but it will be called as a station. See how many stations I will be having here: station 1, station 2, station 3, like this. All these stations, there will be some more parallel stations. If at all I want to work in two different areas, one mission with two different areas, then parallel stations. Okay, next one is assembly station. Assembly, at the same time dismantle. These all are missions. These are all are, what are these? Process defined. Now see, I will be having input. If I connect all these things, at the same time output. This is how exactly I want to create my model. Now what is the thing I need here? See here, there is a input here, there is output I am waiting for, and there are missions. Now if I run the simulation, it won't run. Why? See, if I run the simulation, it won't run. Why it is not running?
So because the processes are not connected.
Yes. See, there are missions I have defined, which means I have purchased some missions, I have arranged them, but I haven't assigned any work. I haven't connected them. That is where we are using this one, connectors.
Excuse me, sir.
Yes.
Sir, which type of machine is it? Means CNC or what?
No, that is second thing. Okay, we will be discussing that in later phase. So whether it is a conventional, whether it is a CNC, that can be defined in the later phases. But now it is just a mission. That's it. Okay.
Okay.
Now see here, I am using a connector. So connector, see, the main usage of connector is connecting between two stations. I have a same connection. Now if I run it, see here, double click this one and there is a pop-up, reset it, and I am running it. Now what is happening? See, there is a yellow button and there is a green button here, which means a part is coming and a process was done. Now why the part is not entering into station 1?
So because station 1 and station 2 are not connected.
Okay, see, there is no any connection between these two. That is why the material is not going. For that again, I need to use connector. 1, 2. If I run the simulation, to reset and run. See, part here, green is nothing but working. So once it was done, again it was entering into this one. After that, again yellow. Yellow is nothing but blocked phase. Why there is a blocked phase?
So because there is no output from station 1.
There is no any connection after this one. So the part is waiting here. Okay, that is why. Again, what we need to do? So if we will be having these many missions, then we need to use a connector to relate two missions, okay, or to give a procedure, to give a process. That is where we are using these connectors, connecting between two stations or connection among all the stations. Here I am connecting. I can define here, I can change the positions here like this. See here, I have defined, I have defined. Now I will be giving this to this one. I don't want these two as of now. Reset the simulation, run. See here, green, second one, third one. See the time. I hope it's visible. 40 seconds, 42 seconds, 45, 46. These are seconds. This model is completely running in a slow speed. If at all I want to increase it, see, that is the this one regulator. If at all I click this one slow, then this process will be visible in a slow manner. If at all I have increased the speed, then everything will be running in a speed. See time also, 12 minutes, 15 minutes. This time is running. If at all I run it completely, that is this regulator bar is okay. I am resetting it. Clear? This is first one is a event controller. What is the purpose of event controller?
Sir, how fast or slow our process will be?
Guys, just a second. Yeah. Sorry, guys. What is the purpose of event controller?
Time, sir.
Okay, to control the complete process is nothing but event controller. Now, next one is a frame. So, frame I will explain you once these things will be confirmed. Then I will be explaining you frame and interface. Now, what is the next thing? Source. What is the source?
Input.
Sir, where the process starts,
Yes,
input.
yes. How the plant, how we are going to give the input to the plant. That is what exactly the source is. Next one is drain. So what is the purpose of drain?
Output.
Output. So how we are going to collect the output? That is a drain. Then these four are missions: single station, parallel station, assembly, and dismantle sections. All these things. Next one is pick and place, which means it is a robot. So if at all I have defined, see, I am deleting this connector. If at all I want to delete it, I can delete, click it and delete. Now I am connecting this with this one and this with this one. Now see what will happen. If I run the simulation, okay, that is what exactly a robot is. In 2D it will be visible like this, picking a part from this one and placing here. In 2D representation it will be like this. In 3D you will be clearly looking at as a robot itself. Okay, that is the main purpose of robot here. Next one is a store. We will call this as a store where the parts will be saved. So I don't want the drain, I want some intermediate storage area where the parts need to be stored. Then I need to use this store to store my parts here. So some other operation will come and pick parts from this one. That is why we are going to use the store. Store is like an intermediate storage. Okay, next one is buffer. What is the use of buffer? I have already explained you. Okay, fine, no worries, I will explain you. This is also one of the component buffer. So why exactly we are using buffer is to store the material. If there are two missions, no, not like this. Now see here, okay, See, I have defined here, which means these station and station 1 are connected to a buffer, and from this it was connected to station 2. Now see what will be happened. The parts will be saved in the buffer so that these mission won't be having any waiting phase. At the same time, these two missions won't be having any blocking phase. See here, now these many parts will be saved in the buffer, so that what will be happen, this process running continuously. At the same time, these two missions are running continuously without having any blockage, but still there is a low blockage because of excess parts, because of limited capacity of this mission. That is why. Okay, so we can change the buffer also. We can change the some important things of this buffer in the later phases. That is the main advantage of this buffer. At the same time, there is one more thing that is called as a sorter. So this sorter and buffer both are same, but what will be happening in sorter is there will we will be having some condition, first in first out as well as last in first out. Based upon that, you can define the condition here. In buffer, what will be happen whenever the part comes? So the first part will be exiting. I mean the first part, it will be here and it will be receiving like this. In this there will be node having all these things. In this sorter we will be having one condition, two different conditions. So how we are going to differentiate, how we are going to distribute our material? So whether I want to distribute with respect to first in and first out, or first in last out, like that I can give a condition. That is why we are using this sorter. Okay, after that there will be having some conveyors. I hope you know the necessity of conveyor to do the material handling. There are five different type of conveyors: straight conveyor, angular conveyor, converter, turntable, turnplate. These are all for the single application, which means for the material handling. And there will be one more thing that is called as a track. If at all I'm using some AGVs, forklifts or human to run, then I'm going to use this one, single track. And there will be a double track, so where I can use a double track for the inward and outward movement. And there will be having flow control, which I will define you in the later phases. These are all, see, material flow. If we come to second one is fluids. Fluid is nothing but these are all for the solid parts. If the input is solid, I mean if it is a raw material is solid, like a SS or MM, whatever the call, I mean component, if it is a solid, then we are going to use this material flow. If the input, if the thing which we are going to monitor is a liquid, then we are going to use this fluids. In this again same thing, connector is the same thing. We are going to use it for the connecting two different stations. Here there is a same source and there will be having a drain. Here we will be having, instead of pipes we will be having a connectors pipe. So why? Because fluids will always flow with a pipe only. So what will be happen if I use a conveyor here? It will be disturbed. So for this we are going to use a pipe. Again there will be having tanks, there will be having mixers, there will be having some portioners, there will be having some different things. With this we can directly use our fluid type of models. So if at all I want to mix two different kind of things, two different kind of fluids, then I'm going to use a mixer. What will be happen, two different pipelines coming to and collect at this mixer. So this mixer will mix all the, I mean coming input, and it will be giving it to the some tank. In tank what will be happen, it will be stored. And how it will be distributed, it will be again connected to this portioner. So that what will be happen, if it is a chocolate, then what will be happen, some 1,000 liters of chocolate, liquid chocolate was prepared. In this portioner what will be happen, it will be defined. If at all I want to collect in a some molds, then I'm using this portioner to define that. At the same time d portioner also, if at all I want to recycle something, then I want to collect all the smaller parts and I want to again recycle something, then I'm going to use a d portioner. So based upon the input we are going to use these fluids. Next one is a resource tab. In this resource tab we will be using humans. Okay, in this material flow what will be happen, we have used all sort of missions that are run for a process. In the resources we are using humans. See how the human place, human footpath. So how the human need to be placed, how a exporter or a broker, so how the AGVs will be lifted, how the shift calendar will be worked, all those things will be done in this resource. And second, next one is the information flow. In this information flow what will be happen, this plant simulation is capable of two different things. One is by using tools, we can define the program, whatever the model we can want, we can prepare here. And there is one more thing that is called as a method, which means programming. So we can run by using a programming also, like Simtalk language. There is some Simtalk language. By using Java, we are going to create some sort of works here that can be defined by using this method. Advanced model, it is advanced modeling. which means if there is a human, I mean, let us take a simple example. There is a mission here and there is a conveyor here. Okay, now the parts will be entering into this one. Now I am using a robot here. I have placed like this, pick part. See, now there is a red line is there. I'll call this as a sensor. So I will be defining what will be to this robot is, whenever a part is coming here, so this robot need to pick the part, or whenever there is a every second part need to be picked by this robot, then this is a advanced modeling. If it is a single modeling, whenever a part is coming, the robot need to pick. For that there is no need of programming. So, but in this condition, every second part need to be picked by a robot and it need to be defined to some other location. Then this is a special clause. At this clause, I need to use some programming. For that, I am going to define a method. And here, I will be giving defined to this one, so that this method will be assigned to this robot. So whatever the program which we have written here, so based upon that only, this robot will going to work. That is method. So for advanced modeling, advanced computing, we are using this type of method. And there will be some more things like variables, tables, all those things defined for this model only. If at all I want to collect some data with this model, then I am going to use this information flow, so that all the data will be collected simultaneously. Next one is user interface. In this user interface, see, there is a mission here, robot here. I can use a note here, comment section. So I can directly write something. Robot for pick and place. Where is it? Sorry. Robot for pick and place. I have defined like this. Okay. What happened? Robot for pick and place. Okay. Now if I double click this one, so there will be a message. Important and OTE. Important and OTE. I don't know why it is not visible. Important note display. Yes, here. IMP and OTE. Important note. So now it will be. So whenever there is important note or a color, so we are going to double click it. In that there is a description here. Robot for pick and place. Generally used for material handling at blockages. Like I have defined some message. So there is an important note here, so that the text person will open it and there will be a message here. Like we can define some set of comments, some set of programming here. There is a buffer is there. Someone may ask what is the need of buffer. So to describe simultaneously, to describe that one, you need to define a comment here. So in that there will be having this thing. So which means what is the need of buffer here? Here right, to reduce the uh, blocking phase of station and station 1 and yes, station is two missions. Like I have defined something, and in the display uh, IMP important, I will be using some color for this red. Okay, so it will be defined like this. So I can define the model whatever it may be. So wherever I want, I can directly define by using this command. So I can open it and I can see the text why exactly it was defined. If there is a conveyor is needed here, so in between these two stations, or if here there is a conveyor is there, so what is the need of conveyor? So to directly answer here, you need to use this type of comments here and you can directly define. So what is the necessity of conveyor? What is the necessity of robot here? What is the necessity of sorter here? So if there is a buffer and there is a sorter, so someone may ask what is the why we can't use this sorter instead of buffer? Then I can, you can directly write in this important section. So if I use a sorter, again there will be having a condition which there is no need of condition like this. You need to write something in this important note. And there is some display. If at all you want to calculate the throughput directly, so how many parts will be entering from this mission directly, you want to monitor that, then you need to define by using these type of display icons. So with this display you can be directly visible how many parts will be done with this one. Next one is charts. This chart is generally used for the tracking for the all these missions. how these motions, how these I mean the second mission, third mission, or zero mission, first mission, how the behavior of these four missions will be there. So how the material will be distinguished. So what is the statistics, if at all I have defined all these things to this one. If I run the simulation, there is a yellow face. So with this yellow face, how can I supposed to say, or how can I supposed to improvise that? That can be defined by using these type of charts. At the same time, there are Sankey diagrams, there are energy calculations, there are a lot of things. After that, mobile units. If at all I want to use some transporters, AGV, forklift, I can define by using directly this one. And user objects, frame. And additional tools like bottleneck analyzer, energy analyzer, experimental manager. These are some additional tools with which I can directly optimize this complete model. Okay, now these are the toolbars that I have defined here. So the same toolbars that I have defined here also. Now what is the necessity of these tools is I can directly use this one. But here see, there is a station 6 and station 1. If I change this station 6, instead of, see what is the time here, I am changing 50. See, the processing time I have changed to 50 seconds. Here this time processing time is 10. Two different things. Now I don't want like that. Directly, see, there is a station I can derive. Just have a look here so that you will be having clear idea. Open, and here I am giving 50, apply. Now if I click this one, if I click this one, if I click this one, now see, this machine is also 50, this machine is also 50, and this machine is also 50. If I use this tool here, see what happened here, it is 10. Okay, see, that is the necessity of class library. In the class library, what I have defined is you can define your own class, you can create your own structure by using all these things. In your model, every mission need to have some 50, like this 50 minutes of processing time or 50 seconds of processing time. So instead of giving each and every mission like this, and instead of changing every parameters here, directly by using class library, and you can change the things like this. Same with the other also, robot, there is a robot here. That robot also you can directly derive, and by using this one you can change the parameters, and you can use this type of robot anywhere with the given characteristics. That is why we are going to use this type of class library. So to get a clear structure, so what is the model which you are preparing here, and after that what is the default tools you have created, derived. So with the tools, what are the different conditions you have given, like all the structure, all the relationship between these tools can be defined by using this class library. Whereas in toolbox there will be having tools with, these are all default tools. So whenever you click a mission, this mission will be imported with the default values, with the default values only. So if you click the turntable, so you will be having a default value only, so you don't have any exact value. So but if you have defined some value to this one, and you want to derive the same application continuously, then you need to derive by using class library, and you can use that one. That is the main difference between class library as well as toolbox. In general, you can use a toolbox whenever you are going to create a bigger models or a larger models. At that time, this class library plays a key role. Okay, for simple model, see here I am using a simple model. For this type of models, there is no need, directly I can use this type of toolbox. If at all I am creating a model, I mean I am creating an external factor, I am external layout, at that points definitely I need to use these things. Why? Because they will be having some relations, there will be having, I can change this name also. Instead of pick and place, I will be using rob1. So I will be using rob1. And here, where is this robot? No, this station I can use this as a ss1. Now if I double click this one, what is the name? Station 7. I can directly define by using this also, ss1, ss2, like I can define. If at all I want to change, I can change by using these things also. This is a frame one I have created. Now I want to add a newer frame. Now in this model is nothing but this is our platform, where we are going to right click. In the right click on the model, we will be having these many things. In that there is a new. So whatever you want to create a new model, or a frame, or a block, or a toolbar. So what is that you want to create? So if at all you want to create a folder, see how exactly it will be. Folder, in that folder I am creating what is the first section? Some painting. This is my painting section, painting folder. In that painting folder, I need to there is a folder created. In that folder, what is the thing I needed to create this type of model? If at all I want to create the model, what is the mandatory thing that will be needed?
Input.
Frame. Okay, on the frame only we are going to create our models. This is a frame. Like that I need to, after creating a folder, see this model is a frame. Like I need to have a frame to model, to processing it. See new, and there is a frame, model frame. Here I need to click model frame. I need to define paint1, paint 1. Now this is my paint 1 frame. In the paint frame, I want mission 1, mission 2, input and output. Now I can connect directly like this. Now this is my paint 1. Once this was done, again I want to create a newer frame. Then again on the painting section, click on the painting. You need to create model frame. Here I want to go spray, not this one, SPRAY, spray paint. Okay, we don't have, we need, no need to use the space. SPRAY PAINT, spray paint. See here, spray paint tab was defined. In the spray paint, I can, if at all I want, I can directly open. So I have defined here. So in this, I can define whatever the things I want. I can use a robot. I can use a here, and I can use this one. And by using connector, I am connecting. Okay. Now see, I will be closing each and everything. One more thing here. If at all I want to delete this one, so you need to click that mission and delete. It will be asking whether you want to delete. Yes. If you want to delete multiple objects, then select, drag and drop all the things like this and press delete button. If you don't click this apply, what will be happen? Each and every icon will be deleting simultaneously. If you click this one, everything will be vanished at a time. Okay, now see here, if at all you want to see all the things, then if you double click this one paint section, then the paint tab will be there. If you spray paint, double click on this one, you will be having this one. If you want to see this model, double click on this one, you will be having this, or beneath you can have this one. That is the necessity of paint. So once you are done with painting, now you want to create some more from the, again for that, here see, no need to create a model here in the painting section. The master model is nothing but model. Here you can define your name as a master. I will be defining as a master. So here in the master, you need to define again a new folder. That folder will be inspection. Again, after the inspection, what is the thing I need to create? See, I have created a folder. After that, what is the thing I need here to create a model?
Sir, frame.
Yes. So here, see, we can't create a frame under this master section. Under this inspection only, we need to create a frame. So you need to click that inspection folder and new and frame. Now your frame will be there. Here, INS1, inspection 1. So you will be having inspection 1 folder. Like that, you need to create your model. So if your plant is having 10 different processes, starting from raw material, cutting, chamfer, some edge milling, drilling, surface grinding, like there will be having 10 different operations. You can define 10 different folders here, and you can create individual also if you are having a problem, and you can directly map by using this interface, and you can connect with using one frame with the second frame. By using this interface you can connect it. Otherwise directly you can create in a single model also, like this. So in a single model you can define like this, even 100 number of missions you can define here. This is also possible at the same time. So these 3 missions are a single frame and these 4 missions are single frame. That also possible by using this plant simulation. Okay, see one more thing here. Once you have created a model, so this is the model you have created. So now you want to save it. For saving a model, file, save as. Okay, in that save as, just keep in mind, don't save in the default directory. Default directory is like on the software, I mean how you have installed, where the installed, on that directory your model will be saved. So here you don't want like that. So for that you need to create a folder I mean wherever you are installed or wherever your drive will be having space. In that you need to create some folder like this plant sim. In that plant sim, you can, if at all you want to create, you can create a direct folder like this. See here, I am creating a folder, new folder. I will be using this examples as a name, and I will be using this. And if at all you want to give frame 1, model model 1, and save. Yes, my model was saved. Once your save was done, then close. Would you like to save your model again? It will ask no need. Why? Because you already saved it. No. So now it was closed. If at all you want to reopen that one, how to reopen that? Open model file. So click on open model file and see here directory. So where you have saved your one, in the practice files there will be example folder and model one. So if you click this one, see here, all the things will be saved here. SS1, RB1, model, model 2, like every frame will be, each and everything will be saved here itself. Okay, clear?
Okay, sir.
This is the basics of the plant simulation. So before starting into it, so you need to have a clear understanding on what is the class library and toolbox. Class library uses it to create a model, interesting model or a structural model, whereas this toolbox use it to create a model with random variables like this. Whatever define, you can define by using directly by using these things, you can define. Okay, initially you are going to use this toolbox only for the tools importing. Once you are familiar with the plant simulation software, once you will be having complete experience on these tools, then you are going to use this class library. Okay, don't use class library as of now. Why? Because you will be having confusion in this. So what if you click this one, there will be having duplicate and derive. So what is the difference between these two things? That is why don't run this model as of now with these things. Once you are familiar with the complete model, then you are going to use a derive, and in that it will be having a simple thing. In that you can, if at all you want, you can directly change. You can want again, you want to derive it, you can directly derive it. Again you want to derive it like this, and you can rename it and you can use it in your model. This will be in the later phases. And the same, but this model, this need to be created. I mean the folder, subfolders, frame, subframe, and main frame. Every model should be having a one main frame, one main directory. Whatever it may be, it's a master, or it's a shoe manufacturing, it's a fan, it's a whatever it may be. So it is a master. In that master you need to have some dummy, I mean sub components, subfolders. Every process will be having sub process name. In that again there will be having some individual frames. Again this thing, once you are familiar with these models, once you are familiar with interface, then it is easier for you. Otherwise it will be difficult. So but try to maintain the name of this directory and this folder as well as frame, so that you will be having a clear idea for the future. Then same thing by using these tools. How we are going to use these tools, I will be explaining tomorrow by using simple models. If at all I want to use the input output, how do you need to use the input, how we need to use the source, how we need to use the stations, parallel stations, all these things we will be learn step by step from tomorrow onwards. Okay, clear with the basics this thing?
Yes, sir.
There will be a lot of other things that are involved in this plant sim also, that I will be explaining in a day by day basis. Whenever the component is come, see here there is a robot is there. So whenever the robot topic comes, then I will explain you in detail all the things involved in this robot. So what is the angle, timetable, what is the time factor, how we are going to use this lead time. So all those things will be discussed when this chapter will comes. Okay, fine.
Fine,
Okay,
sir.
sir. Yes, sir.
Now that is why I am telling you, so the software is one of the key thing. Now you need to have the software with you, so that you need to have the, I mean you need to practice all the things. Once I am explaining you, once I have done the explanation part from my side, and you have the whole day. So like the hardly explanation will be 1 hour. So after 1 hour I will be closing the session. So whenever you will be having a doubt, so directly you can ping me, or directly you can contact me by using this classroom link, and you can pose the doubt, or in the next day session you can directly ask the doubt, and we can clarify over there. Okay, like that the session will going to happen. So if you are having a doubt again this thing, don't worry. So until unless you will be expert in this, so if you are having a doubt, you can ask me, no worries in this. So like, if I say like this, mission output, I have connected. But if you are having difficulties in connecting, no worries, try practicing it. Still if you are having any doubt, no worries, in the next day of the session or in that day itself, you can directly ask me, So why exactly it was happened, so what is the alternative things, like based upon the question and answers we will be explaining the complete session or complete software. Okay, clear?
Sir.
Okay.
Yes, sir.
Okay,
Yes, sir.
fine. That's it from today's session. From tomorrow onwards, we are going to learn the software completely from starting. How, if at all there is a source, what is the usage of source? If there is an event controller, how to use an event controller from the starting step. So we're going to learn from tomorrow onwards. Today, try to check all these things. So whether the software is opened or not. At the same time, how to save a directory. So what are the tools? Whether these tools will be visible with you or not, visible for you or not. At the same time, this structure is visible or not. So all the things, once I have a check on it, once it was for me, I mean once everything is running perfectly, then if at all you want to save, you can directly save a model by using a model 1 or model 2 or a draft 1 draft 2, like so whatever the name you want, you can save with it and you can close the software. Okay, fine. That's it from my side, guys. Anything you want to ask?
No, sir.
No, sir.
Okay, fine.
No, sir.
Chalo, then have a great day. Bye.
Thank
Thank
you,
you,
sir.
sir.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Thank you.